When we're expanding and simplifying, all we're doing is just expanding the binomial that we have here. So the first term is x. We're going to multiply that by everything in the second bracket to get x squared plus 4x, as you see. Now we're going to do the same thing for the second term in the first bracket, and we're going to get negative 7x and minus 28. Now what we need to do is we need to pull in the middle terms together. So we start with x squared. We add the two middle terms, 4x and minus 7x, to get minus 3x, and then we bring down minus 28. And we're done. Now for the next problem, we have 2x plus 9 all squared. Now let's highlight the fact that we're doing the squared term. The squared term really tells us that we have to basically repeat the brackets twice. Okay? And once we've done that, we're going to get something like this. 2x plus 9 times 2x plus 9, both in brackets. Now, once we've done that, we have to expand as normal. The 2x times the 2x and the 2x times the 9. And then we take the 9 in the first bracket and multiply by everything in the second bracket as well. So when we write our second line, we're going to get, well, 4x squared in blue plus 18x plus 18x in red, because we took this 9 times everything in the second bracket, plus 81. And now let's collect the like terms. The only like terms are in the middle, so we're going to start with 4x squared, nothing to change, but we're going to end up with positive 36x plus 81. And we're done. Now, let's move on to the next problem. This next problem is dealing with an area. So we're going to calculate a simplified version of the area for this expression. So all we're going to do is we're going to take our time and we're going to break this problem up into two parts. Now, this bottom line that I've highlighted is going to be 3x plus 2. Now, how did I get that? Basically, you're going to take 4x plus 2 and subtract x. Now, that comes from the line that's on the top of the shape, subtracted from the parallel line x on the bottom. So you get 3x plus 2. So now let's go and break this whole problem up into two area calculations. In order to do that, we're going to draw a line up from the kinked corner in the bottom right, in the bottom portion here, and you'll see how I break this up. So we're going to base our first area, let's call that A1, going from the side 2x plus 1 and 3x plus 2. Now we know that the area is length times width, so all we're going to do is we're literally just going to put in each side into this equation, then we're going to expand it. So we're going to get the following. I believe it's going to be 2x plus 1 in brackets times 3x plus 2. Now let's expand. So you're going to get 6x squared plus 4x, and then 1 times everything in the second bracket to be 3x plus 2. Collect your like terms. 6x squared doesn't change, but the middle terms add together to get 7x plus 2. And now we're left with A1 equaling 6x squared plus 7x plus 2, and we're just going to highlight that. Now we're going to go and identify the second area that we need to add in order to get our final area. I'm going to call that A2, and that's going to be in blue. Now A2 has a length of 4x plus 3 and x. So let's go with our length times width calculation. And that's going to be 4x plus 3 times x. Now imagine 4x hits the x, then 3 hits the x. So the 4x times x will give us 4x squared plus 3x in green. And that is what our area is. We're done. So that's what area 2 is. So let's identify area 2, and then we'll figure out how to calculate our total area. Yeah, that should be it. And now we're going to go and identify how to calculate the total area. So the total area is going to be a sub 1 plus a sub 2. So let's go and actually write that out and see what we get. Now, you're going to have a sub 1 plus a sub 2. And what you want to do is you want to leave everything in brackets. Okay? You always have to put whatever you're substituting into the equation in brackets, because you might have to deal with a minus sign at some point. So in this case, a1 is 6x squared plus 7x plus 2, and a2 is going to be 4x squared plus 3x. Alright, now that I've got my 3x, my stuff dumped in, the plus sign in between those brackets doesn't mean anything, doesn't change anything. So I can just drop the brackets between both of these equations to get 6x squared plus 7x plus 2 plus 4x squared plus 3x. Now, let's put the like terms that we have together side by side. So on the next line, you're going to get 6x squared plus 4x squared. And then you're going to go and put all the x terms together. So we've got 7x plus 3x. And then finally we have plus 2. Just tacked on to the end because there's nothing else added there. So now let's go and bring the like terms together. So 6x squared plus 4x squared is just 10x squared. And then 7x plus 3x is going to give us 10x. And then finally, we have left over just plus 2, so we'll just tack that on the end. And that is our total area. 10x squared plus 10x plus 2. And that is our total area. And that's our simplified expression that we're looking for. So now, let's move on to changing relations into from vertex to standard form. Now, for this type of problem, notice I've got something squared. So what it means is we have to repeat that bracket. And then we just write everything else as it was before. Now let's go and simplify. So we get 0.5, and inside the bracket we're going to get x squared minus 10x plus 100. And bracket plus 4. Now let's simplify by bringing the two numbers in the middle inside that bracket. So we're going to get 0.5 bracket x squared minus 20x plus 100 and bracket plus 4 still. So now we're going to have to take a look at the 0.5. And we're going to multiply it by everything inside that bracket. So there's 3 lines that go into it. So we end up with negative 0.5 x squared. Now, the next one you're going to get plus 10x, because negative times a negative is a positive. And then we do the same for the last one as well. So we end up with minus 50. And you'll notice that the bracket just disappears once we've done that. And we add the 4. So now we simplify by collecting the ending like terms, because there's two constant terms. So we get negative 0.5 x squared plus 10x minus 46. And we're done. There is our relation in standard form. Now, this next one asks us to find the y-intercept of the relation. There are 2 ways to do this. I could have taken this equation and I could have expanded it. But another way of doing it is just simply letting x equal 0. So if x equals 0, then we have 3 times 0 plus 2 all squared minus 1. And we simplify the bracket, so we get 3 times 2 raised to the power 2 minus 1. 2 squared is 4, so now we have 3 times 4 minus 1. And we end up with y is equal to 12 minus 1, which is equal to 11. So this is our y-intercept. This is our y-intercept. So when we let x equal 0, solve for y, that gives us our y-intercept. So now let's go and look at the other equation to the right here. Now this problem, it's already in standard form. It's already been, the vertex form has already been expanded. So all I have to do is either let x equal 0 or simply just understand that's it's in the standard form. And the standard form, all you have to do is look for the only term in the entire list that doesn't have an x added to it. So in this case, the y-intercept is negative 8.2. And we're done. Now for this next project, it's asking us to basically take something that is in vertex form, and we're going to take it and we're going to convert it into standard form. But we first need to know what the vertex is of our equation. So let's figure out what we have to do here. Now, it says t is in the time for second, so that's going to be like our x value. Y is going to be our height. H is going to be our projectile's initial height. And v is going to be our initial velocity. So I'm going to use x instead of t. You could do that on your test. Your vertex in this case is 3, 50, because we knew that y is the height, so 50 has to be on the right side of the vertex point. So now we start with y is equal to negative 4.9 bracket, and we go x minus 3 all squared plus 50. Now the reason why we got negative 4.9 is because our original equation had negative 4.9 being attached to the t squared term. So we need that in order to do most of our calculation. So that's our a value. So now let's go and expand this, because we're going to change it to look something like our original equation up top. So we have x minus 3, when we simplify it, squared is going to be x squared minus 6x plus 9, and that's plus 50. Now we're going to take the negative 4.9 and we're going to multiply it into everything inside that bracket. Doing so, you're going to end up with y is equal to negative 4.9 x squared minus 29.4 x plus minus 44.1 plus 50. Now what we have to do is we're just going to collect the like terms, which are just going to be the only like terms that are the similar are going to be the 44.1 and the 50. So we're going to get negative 4.9 x squared plus 29.4x plus 5.9. So now, if I look back at the original equation, it said the initial velocity was the second term in that list, the one that had the single x term or t term. So our initial velocity is going to be 29.4 meters per second. Okay, and the initial height is going to be the starting height, which is just going to be 5.9. And that is at the end of our bracket, of our equation. And now we'll start moving on to factoring. Let's begin. So, oh, sorry. All right. Now let's move on to factoring. All right. So now, x squared minus 12x. In order to factor, you're just going to pull off an x. So you're going to end up with x bracket x minus 12. Next problem, b. We have a 3-term polynomial. We have to look at the last number. We have to find all the multiples of 10. We have 1 times 10 and 2 times 5. Now we need to pick the one that adds to 11. And that turns out to be 1 and 10. So let's go and write our brackets. So we're going to have x bracket, x bracket. And we're going to put a 10 and a 1 in both of them. And then, because it's adding up to 11, both of those numbers must be pluses. Alright, let's move on to the next one. We have x squared plus 12x minus 13. So, in this case, we need to have two numbers that multiply to negative 13. So let's go and figure out the multiples of 13. So we just got 1 and 13. We're done. So let's go and write our brackets out. So we're going to have x, and one of them is going to be 13 and one of them is going to be 1 inside our bracket. Now, in order to get positive 12, we need to have positive 13 and minus 1 in order to do that. And that's because the minus 13 must have at least one negative number and one positive number. And we just have to mix and match until we get the right result. Alright, and now let's move on to the next problem. So we have another trinomial, and so we need to have all the multiples of 24. So we got 24, which is 1 and 24. Also 2 times 12 gives 24. Also 3 times 8 gives 24. And 4 times 6 gives 24. Which one of these would work? So let's start by writing x bracket and x bracket. So we need two numbers that somehow add to 5, negative 5. So we're going to use 3 and 8. So we're going to put 8 and 3 in there. And we have to figure out what it's going to be. In order to make it negative, I have to have negative 8 and plus 3. And that's what we're going to put in our brackets because there is only one negative and one positive for our result because our final answer is negative 24. So let's just put that in. Let's go. So we end up with negative 8 and positive 3. Because negative 8 plus positive 3 gives negative 5x. So now let's go take a look at this next problem here. We have x squared minus 12x plus 36. So let's break down 36. And we'll also make sure we have our brackets set up right away. So we have 36. It breaks down into 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So now that we've got those, we have to find something that adds to 12. Oh, it's got to be 6 and 6. Now, it needs to add up to negative 12. Now, just like before, think about it. We have a positive 36. So I could either have two negatives or two positives. So we're going to make sure that both of them have negatives. Okay, now this last one. This is just a difference of squares. Nothing difficult. You got 1 and 49 and 7 times 7. And 1 must be negative and 1 must be positive. That's it. We're done. Now, let's do the last problem of the day. We're going to calculate the area of that shaded region. Now, the outside region, let's call it A big. A big is going to be just x times x, which gives us x squared. So let's just write that out right now. So now, alright, so now let's figure out what the small area is. The small area is, there's 9 4 centimeter square blocks. So we're going to go 9 times 4, which gives us 36. Now, they've asked us to write a factored expression for this. So we're going to write A big minus A small, which is just literally x squared minus 36. Now that you've got that, you'll notice that it's a difference of squares. So we're going to write this as x minus 6 and x plus 6. And we're done.